Hello and welcome everyone to my channel Code with Ease. Today, as part of the array series, we are going to learn this question called the rotate array. So, we are given this problem statement where given an array, we have to rotate the given array to the right by k steps, where k is non-negative. So, basically this is a right rotation of an array. So, as we can see in the first example that this is the given array and k equal to 3 means the array will be rotated 3 times. When we are doing that, this is the output array that we get. We don't have to output the array, but we just have to do in place rotation of the array, right rotation. So here the explanation, when we are rotating for the first time, so right is like circular right. So this element, the last element will come at the beginning, then the second last element will come at the beginning, and finally the third last element will come at the beginning. The requirement is we have to do it in place without using any additional space. So with that, now let's try to discuss the approach for solving this question. Okay, so we are going to start with the approach for doing this. So as we always discuss the brute force way, here's the array and here is the k equal to 3. Okay. So now that we already know that we are not supposed to use extra space and all of that because of the constants which is given over here, but let's say we were not aware of it. So what we would have done, the naive way of thinking, like the initial thought process could be, what we observe is if we see the output when k is equal to 3, the last 3 elements have come in the beginning and the rest are at the end. So by seeing this, by the looks of it, initial thought process could be, let's say we take a temporary array and just copy the last 3 elements to that temporary array and copy the rest of the elements at the last, which means if k equal to 3 and n means the total length of the array is 7, 7 minus 3 is 4. So if you notice from the 4th index till the last, if we copy the element from the 4th index till the last into this temporary array, and then we will just append the rest of the elements to it and we can return this temporary array. But that surely will not be an in-place rotation of the array also. So two things we are violating. We are violating the space thing also, we are violating the in-place. So I just want to discuss about, just to give a very basic idea of what rotation actually means. Next is, now we will of course try to not use additional space and try to do it in place. So this is approach number 1. Second is, what we can do is, let's say we have a for loop where we start from int I equal to 1 and we iterate this till whatever the kth value is. So whatever the value of k is, that many times the loop is going to run. So let's say we do this. Within this loop, what we will do, for every kth rotation, we are going to do this steps actually, whatever is given in this explanation. For every kth rotation, we are going to manipulate the existing array by, how can we do this? Because it's a right rotation, by moving the last element to the beginning and shifting rest of the elements. So in that case, what we can do is we can take a variable to store the last element, whatever we have. Because if 7 has to be moved at the beginning, then 6 has to be in 7's place. If I move 6 to the last position, I'm going to lose out on the last element. So first of all, I will store it and then I'll do the shifting. So how am I going to do the shifting? So in this case, it is going to be array of I. Okay, by the way, this is not happening inside this loop. Inside this loop, there's going to be another for loop which is going to happen. Which is going to run in the backward direction, like from int I equal to n minus 1 till the forward. So inside the second loop, all of this is happening. So inside this, what we will do, ARR of I is equal to ARR of I minus 1. Simple thing, like in the place where 7 is there, I'm going to put 6. Whatever the element before this is there, I'm just going to put 6. So 6 will come over here, 5 is going to come over here, like that. It is just doing a right shift. And the element 7 I've already stored in this variable. And finally, I'm going to put ARR of 0 outside this loop. I'm going to put ARR of 0, whatever is the stored last number is there. So this is the second approach that we can do. We'll take one loop to track how many rotations we are doing, whatever is the value of k, and inside that we'll have another loop in which we are going to do the actual shifting logic. Problem with this approach, as many of you would have already guessed, the time complexity. We are using 2 for loops. We are going to get a time complexity of k into n, because for every kth value, it is running n times. So the target would be, of course, to not use additional space. The target would be to, of course, do a n-place rotation. And the target would also be to achieve a time complexity of order of n. Okay, so let's see how can we do that. Okay, so we are going to talk of the optimal solution now. So let's say we have this array. So what we discussed is the target is to do it in place. The target is to not use any additional space, and then try to do it in optimal way, like in order of n or something. So what we can do is, since we know that in the output, these are the 3 numbers, like when k equal to 3, the first 3 numbers are coming at the beginning, followed by the rest of the numbers. So what we will do, first of all, we can reverse this array. So let's say I reverse this array. So when I reverse it, it will be something like this. Okay. Now see this reversed array and see this output array. What do you think we need to do to convert this output array, to convert this reversed array into this output array? If you notice this part and if you notice this part, there is the answer. So basically, this reversal is the trick for achieving the optimal solution. What we have to do is, number one, we have to reverse the entire array. Second is, we will do partial reversal. What does partial reversal mean? If you noticed, the first three elements, because k is equal to 3, this portion of the this part of the array, if we reverse this part of the array, what we will get? We will get 5, 6, 7. Similarly, if we reverse this part of the array, we will get 1, 2, 3, 4. When I say reverse, I basically mean, let's say we have a 2-pointer algorithm and we keep on swapping. 1 and 4 get swapped, 2 and 3 get swapped. So it's as simple as you reverse from 0 to k minus 1, the index 0, 1, 2, and then you reverse from k to n minus 1. That's it. So we can write one method to reverse array, and then we can pass in the pointers, the start and the end pointers, and within the range of the start and the end pointers, our sub arrays will get reversed. And as a result of that, we will be able to achieve in place rotation of the array. What is the time complexity of this? Order of n. Because although we are splitting this array into two halves, in a way we are traversing the entire array only. Now let's try to write the code for this. Okay, so now we are starting with the code changes. So we have to write this method to reverse the array. So we can call this reverse. And then in this, we are going to pass in the array and the start and the end pointers. Okay. So in the first case, since we are reversing the entire array, so it is going to start from 0. And then we will have to also take the length of the array. So nums.length. And we can say reverse it till n minus 1. This is going to be the first call. So it's going to be the first method call. Second time when we are going to reverse the same array from 0 to k minus 1. Finally, we are going to reverse the same array from k till n minus 1. Now we'll write the logic to reverse this array. So we have the start and the end pointers. We'll just write this while loop, while start is less than end, and we are just going to use this 2-pointer logic. So in that we use this temporary variable and we say ARR of start we are going to store in that. Then in place of ARR of start we are going to put ARR of end, and at ARR of end we are going to put whatever we had stored in temp. And then we are also going to do start plus plus and end minus minus. So that's about the reverse logic. And so we have 3 calls. First, to reverse the entire array. Second, to reverse from 0 to whatever the k, the value is. So just that many elements, covering that many elements, that sub array. And the last will be to cover the rest of the elements and reverse that. So with that, we'll run this. Okay, we'll submit. Array index out of bounds. Okay. So it's a single element is there. So if single element is there, then k is 2. So in the second method call, it is going to be 2 minus 1, 0 to 1, and 1 doesn't even exist. So this is the edge case. Okay, so if there is only one element, then obviously this method call is going to break. But we also see, if there is one element, we might also want to rotate it 10 times, and even if you rotate it 10 times, it will still produce the same answer. Like minus 1 will remain same as is. So in that case, what we can do is we have to tweak this value of k such that we have to tweak this value in terms of the length of the array. So we can say k equal to k mod n, which means that if, let's say, k is equal to 3, like our initial this thing, if k is 3, so 3 mod whatever the length is 7, so it was coming as 3 itself. But if the length is 1, it will come as 0. So if it comes as 0, then we are sorted. It will not break. The problem is only if it comes anything other than 0 in case of single element. We'll try this. Yeah, so that was the thing. Small thing which is going to cover the edge case. So yeah, that's all about this question, how to rotate an array to the right by case steps. So yeah, that's all about this question, how to rotate array to the right by case steps. Hope you guys have enjoyed the session for today. Thank you so much for watching.